two problems in quiz 8.3. First one says, if an object is thrown downward with initial velocity of v sub 0, then the distance it travels is given by this equation here. So s actually stands for the distance. So then we have an object is thrown downward from an airplane 200 meters from the ground with initial velocity of 6 meters per second. How long does it take? So I tried to color code it. How long is talking about the time, which is what t stands for. So we're trying to solve for t. We know 200, which is the s, which is the distance, then we know 6, which is the velocity. So we put everything here in the equation. Again, I tried to color code it. Move everything to one side so it's equal to 0. Plug it in the quadratic formula since we're trying to solve for t. And we get two possible answers here. We throw out the negative one since time can't be negative, so we have this final answer of 5.81. The second problem says during the first part of the trip, canoeist travels 95 miles at a certain speed. The canoeist travels 12 miles on the second part of the trip at a speed 5 miles per hour slower. The total time for the trip is 2 hours. What's the speed on each part of the trip? So we make a little chart here. Distance is always equal to rate times time. I labeled the first part of the trip and the second part of the trip. So the distance is 95 in the first part, 12 in the second part. We don't know the rate for the first part of the trip, but we know the second one is 5 miles per hour slower than the first one. So that's why I wrote the r minus 5 here. We also know that the total time of the trip is 2 hours. So we could do t1 and t2 here and then add them together and get 2 hours total, but if I just label this one as t, then the second part of the trip is going to take 2 minus t. So that together, when you add these together, you'll get 2. So then we set up our two equations. From here, 95 equals r times t is the first one. Second one, 12 equals r minus 5 times 2 minus t. We're going to use substitution, and so I solved for t in the first equation by dividing by 95 on both sides. Going to plug that into the t spot here, which gives us this. Once we FOIL it out, we'll have this right here in black. Then we want to get rid of the r on the denominator spot. So we have to multiply through by r to everything here inside. That way this r will in the denominator spot will be gone. So then we are left with what's up here in black. And you can pause this video if you need to look at my work and check my work. So then we want to get everything to one side because I notice it's a quadratic equation. So I subtract 12r, combine all these r's together, makes a negative 117r. Make sure it's equal to 0, that way we can use the quadratic formula and we get these two answers here. Well, we have to throw out actually the 4.38 for the speed, because if that was the speed for the first part of the trip, when we subtract 5, the speed for the second part of the trip would be negative, and that doesn't make sense. So we have to throw that out. So 54.1108 is the speed for the first part of the trip. To find the speed for the second part of the trip, we would just subtract 5 from this, and that would be our two answers.